Hey there. So, are you staring at that Math Models Practice Quiz 1 and feeling a little bit stuck? Yeah, I totally get it. In this quick guide, we're going to break down some of the key problems, step by step. The goal here is to build up your skills and, maybe more importantly, your confidence.
You know, a quiz can feel like this big, scary final boss in a video game, right? But here's the thing. Our goal isn't just to hunt for the answers, it's about mastering the method, the how behind them. We're in this together, and trust me, by the end, you're going to have an awesome toolkit for solving pretty much any problem they throw at you.
Okay, first up, let's crack the math code. Honestly, sometimes the hardest part of a word problem is just figuring out what on earth it's actually asking you to do. So this first section is all about that, turning those confusing words into a simple math equation that you can actually solve.
All right, here's our first example, pulled right from the practice quiz. Now, it looks pretty simple, doesn't it? 22% of 2 million. But what it's really testing is a super important skill. How do you take words like percent of and turn them into actual math? Let's dive in.
Okay, here it is. The secret key that unlocks this whole problem is one tiny little word, of. Seriously, whenever you see the word of sitting between two numbers in a math problem, I want your brain to just immediately shout, multiply! That's it! That's the secret code!
So this is the right answer from the multiple choice options. But wait a minute, why is it 0.22? Why not just 22? That, my friends, is the second part of the code we've got to crack.
Yeah, you can't just throw the number 22 into the multiplication. See, percentages, they have to be converted into their decimal form before you can use them in an equation. So this little three-step process, this is your go-to game plan for any percentage problem. Think of it like a simple recipe you can use over and over again.
And how do we do that? It's super easy. To turn a percent into a decimal, you just move the decimal point 2 places to the left. So 22%, boom, becomes 0.22. And just like that, our phrase, 22% of 2 million, turns into this beautiful, simple equation right here.
And when you punch that into your calculator, and you should definitely use a calculator, that's what it's for, you get the final answer, 440,000. And there you have it. Problem 1, done.
All right, let's keep the momentum going and jump into our next problem. Now we're going to see how these skills start to stack up. We're looking at a problem that feels a lot more like something you'd see in the real world. Now, these multi-step scenarios, they can look really complex at first, but the secret, it's always just breaking them down into smaller, bite-sized pieces.
Okay, so let's picture this. We've got a rectangular field. We need to put a fence all the way around it. And the big question is, what's the total cost? That phrase right there, total cost, is a huge clue. It tells us we have to figure out two things. First, how much fence do we actually need? And second, once we know that, what's it going to cost? So that first piece of the puzzle, the total length of the fence. Since a fence goes around the outside of something, we're talking about perimeter. And you probably remember this one, but the formula for the perimeter of any rectangle is just 2 times the length plus the width.
So here's our two-step game plan. It's super simple. Step 1, calculate the perimeter. That tells us how many feet of fence we need. Step 2, take that number and multiply it by the cost per foot. See? When you break it down like that, it's way less intimidating. Okay, time to plug and chug. Let's get the numbers in there. We add the length and width, so that's 640 plus 880, and then we multiply that whole thing by 2. That gives us a total perimeter of 3,040 feet. Awesome. Now for the easy part. We just take that length and multiply it by the cost, which is $12.40 per foot.
And voila! That brings us to our grand total, $37,696. See how that worked? We took a kind of big, messy problem and broke it into 2 smaller, easy ones. Perimeter, then cost. That's the key to solving these things cleanly every single time.
All right, for our last section, we are tackling a concept that sounds kind of fancy, but it's really not so bad. I'm talking about scientific notation. This is super useful for scientists and engineers, or really anyone who has to work with crazy big or ridiculously tiny numbers. At the end of the day, it's just a shortcut, a more efficient way to write those numbers down. So let's just look at the difference. On the left, you've got your regular, standard number, and on the right, you've got that same number in scientific notation. The pattern is always the same. It's a number between 1 and 10 times 10 to some power. And here's a quick tip. A positive exponent, like that 7, means you're dealing with a really big number. A negative exponent means you've got a super tiny decimal.
Okay, so with that in mind, let's look at this problem from the quiz.
Now we're being asked to multiply two numbers that are already in scientific notation. And the great news is you don't have to guess. There are very specific, very easy rules for how to do this.
And I mean it. The rules are surprisingly simple. You basically just tackle the problem in two parts. First, you multiply the regular numbers in the front. Those are called the coefficients. Then, for the powers of 10, you just add their exponents together. That's it.
So let's actually do that right here. We'll take the front numbers, 3.2 times 1.5, that gives us 4.8. Easy enough? Then we take the exponents, which are 5 and -3. We just add them. 5 plus -3 is 2. So we just put those two pieces back together, and we get our final answer. 4.8 times 10 to the power of 2. See? Not so bad.
So we just blew through three totally different types of problems. But you know what? The real win here isn't just getting three right answers. The real goal was to build a powerful set of strategies, a toolkit, that you can use to face any problem that comes your way.
So this right here, this is your brand new problem-solving toolkit. It's simple, right? Translate the code words like of and percent. Break down those big, scary word problems into smaller steps. Find the right formula for the job, like perimeter. Remember the simple rules for things like scientific notation. And seriously, use your calculator. It's a tool, not a crutch. It lets you focus on the how without getting bogged down. These strategies are the real key. Because here's the cool part. When you have a method, a process you can trust, math stops being this scary thing about finding one right answer. It becomes a way of thinking, a way of solving puzzles. So my final question for you isn't about this quiz. It's about what comes next. Now that you've got this toolkit, what other problems in the real world are you ready to solve?